Computers are often referred to as thinking machines, but how do they actually process information and make decisions? It all starts with logic. Inside every computer, there are billions of tiny components called transistors. Without logic, a computer wouldn't be able to function. The logic process used by computers allows us to perform various tasks, from typing documents, accessing the internet, playing games, to running highly complex software. All these operations are carried out very quickly thanks to the processing of information in binary form, which is 0 and 1. The computer can transform this information into results that humans can understand, from mathematical calculations to interpreting data and making complex decisions. Computers rely on logic gates, which depend on the combination of transistors, to carry out these operations. As technology advances, computers are now used in almost every aspect of human life, from education, business, healthcare, to entertainment. So, behind every function of the computer that we enjoy, there is a sophisticated logic process that makes it all possible. Transistors, which consist of 3 layers of semiconductor material, play an important role in computer operations. These layers are known as the emitter, base, and collector. This unique combination of materials allows transistors to act as switches or amplifiers. As switches, transistors can turn the flow of electricity on or off, which is equivalent to representing binary numbers 0 and 1. This is what enables computers to perform calculations and logic operations very quickly. Therefore, when transistors are combined, they form logic gates. Logic gates are the basic components that process information in binary form, 0 and 1. Let's take a look at the 3 most common types of logic gates: NOT, AND OR. The main function of this logic gate is to serve as the foundation for forming digital circuits so that all components can be connected or integrated properly. The better the connection between these components, the better the electronic device will function. This logic gate actually acts as a system used to translate or instruct an electronic device to operate. This is the NOT gate, one of the simplest logic gates in digital circuits. The NOT gate acts as an inverter, taking a single input and reversing its value. If the input is 0, the output will be 1, and if the input is 1, the output will be 0. It essentially changes the input to its opposite state, which is why it is often called an inverter. The NOT gate is essential for many digital operations, as it forms the basis for more complex logic functions and helps in creating control signals. Take a look at the truth table. Notice how each input results in the opposite output. The AND gate is one of the basic logic gates with 2 or more inputs and a single output. The output of the AND gate will be 1 only if all its inputs are 1. If any input is 0, the output will be 0. The AND gate is commonly used in digital systems to ensure that all necessary conditions are met before producing an output. For example, in signal processing, the signal will only be passed through if all input conditions are satisfied. The truth table shows that the output is 1 only when all inputs are 1. The OR gate is an essential component in digital logic circuits with 2 or more inputs and a single output. The output of the OR gate will be 1 if 1 or more of its inputs are 1. The output will only be 0 if all inputs are 0. The OR gate is often used to make decisions or trigger conditions when one of several requirements is met. For example, in alarm systems, the alarm will activate if one of several sensors detects a condition. The truth table shows that the output will be 1 if any input is 1. Now, here's a look at how this video was made using Blender and various animation techniques.